Welcome back. Okay, this is the second ever episode of the KixxCast with me, Simon, and of course, Kris, creator, inventor, innovator of the Kix Framework. Morning, Kris.
Good morning. Hello.
And I've been really stoked on the project. I've been getting a little bit deeper into my own first party discovery of it, and I was hoping we could talk more about kind of the framework, your thinking, and maybe the ingredients or components of what make it special or interesting. How's that sound?
Yeah, sounds great.
Cool. So one of the things that you talked about when we were first discussing the project and that got me really interested was this idea of a primitive or an atomic object. Maybe you could go a little bit more in depth on that. What is that? How is it special in this project? And how are they represented in the code?
Yeah, the idea of assembling software from primitive components is nothing new. I mean, that's been around for a really long time. I think what's could be different and really interesting about the future is how we train AI tools, specifically large language models, to understand how those components work. And a developer then becomes not necessarily a person who's typing out thousands of lines of code, but one who's orchestrating how components fit together, which I think is super interesting. So you can think of components like primitive components on a few different levels. Cloud computing has kind of brought a different sort of popularity to it, where you have things AWS really kind of set the stage for how we think about this. With its early, it has a storage component, Amazon AWS S3, where it's basically a file storage system, but it's distributed and all managed for you. There's relational database systems, there's document database systems. None of these things in and of itself would make an application or really make an application interesting. But what's really interesting is that you can string these things together and connect them to build applications. So they're really these fundamental Lego bricks. And I think that's why programmers call them primitives, is because it's the lowest fundamental layer that you can get to, that really doesn't have a lot of meaning on its own until you start to orchestrate it, connect it with other pieces. I was first fascinated with this idea when I was doing some work on Firefox, which is an open source project. And this would have been 2009, 2010. And Firefox is built on what's called an XP which is cross-platform components. And each of the components is its own discrete little module, and you could add new components into the ecosystem if you wanted to. So some common components, of course, in a web browser, would have been the networking component. There was an observer model where you could subscribe to certain places in the system that would emit events. So when Firefox starts up, there's certain things that happen with the operating system as it's booting up, and you can listen to those events and then react to them and start your own plugin or whatever the case may be. And then you could write your own components and add them into the Firefox ecosystem in the form of plugins. And this was just fascinating to me that, someone would think that far ahead of let's make an extensible system that can be worked on and sort of modified and personalized for each installation. So that was also super interesting. And then lastly, the MVC web frameworks, primarily Rails, so model view controller. Rails, sort of Ruby on Rails, adopted some of these concepts, namely the model concept, where you have an object called a model, and you create a class, and the class can then basically instantiate thousands of instances of this model. And the model could be anything. It could be a user. It could be a record in the system or something like that. And most models in the MVC system, like Rails, are stored as rows in a database table. And then you sort of build an application off of those primitives, models, views, and controllers. And so that's what Kix really is it's taking all these historical concepts from cloud computing, from MVC frameworks, from client-side application frameworks, and it's sort of borrowing pieces from all of those things so that we have our own set of primitives that we can then use to string it together. And you don't need an LLM to do this. It's a
Hmm.
lot of fun and really fast to do it, just like as a programmer. You put, you know, make your models, you can define them in one or two lines of code, and you hook them together with your forms, which are your inputs, and
Hmm.
you can query them with your views, which mutate the data into various useful forms and sort it and page it so you can paginate through the data. Um, and that all that stuff is there for you in the framework already, and as a developer you just sort of become the orchestrator that puts it together. It's a lot of fun. I've been having a blast working with it.
One of the things that you mentioned at the top there is this idea of like training humans, but also like training models or training like AIs or AI agents, I suppose. What's your sense of the difference there? Like how, like what are the useful ways to train people? Like what are the useful ways to train AI? And like is Kix unique in this way? Or is this sort of a broader like mental model that you're applying?
um it's not unique. It's only unique in the sense that it simplifies what a person needs to learn to develop the software. So you can just scratch the surface a little bit and not learn very much and get pretty far. Or you can dive in and you can learn a lot and build much more advanced things. So this allows someone to start slow, build something interesting, and then iterate on it on an actual product.
Hmm.
Um, and that and that just comes from, documenting. You would only have to read the documentation for a couple of things to get started. And then as you dive deeper, you could read the documentation for more. And the documentation is short, succinct, and you can what what's really great about small components is you can fit the whole thing in your head at once and think about it. So while you're working in that context, you're thinking about one or two or maybe three at the most components.
Right.
Uh, and how they would fit together in the larger ecosystem. So let's say you want to do email confirmations when someone signs up. So, okay,
Hmm.
so I need to use the email component. And how do I send regular emails? Well, there's a job scheduler. That's another one of the primitives. So we've got an emailer and we've got a job scheduler. So we'll use the job scheduler to schedule an email every time someone signs up. Um, for a new account for our application. And so those are just the two things you have to have in your head to do that feature. The job scheduler and the emailer on their own don't do anything special, but it's kind of cool if you when you hook them
Yeah.
together, you can fire off a job that would then send confirmation emails. And so that's a new feature. And you don't have to read much or learn too much to be able to do that, but it feels much more advanced than when you first launched the application and didn't send emails.
Yep.
Um, where that gets really interesting is that today, and I think this is going to change in the near future, but today, most coders are using LLM code generation tools to write all the code to
Hmm.
do all those things. With
Right.
this, what we're doing is we're giving the large language model just the context for those two components that we want to hook together, the emailer and the job scheduler. And it's
Right.
very easy for an LLM to digest the documentation for those two things. And then say, oh, you want to send out an email when a new user account sets up. Okay, well, that's easy to do. And it really, it is generating some code to hook those things up, but it's
Mm-hmm.
very minimal. So the output is small. So we that solves a couple of problems. First is that like LLMs really struggle with like large context. So
Right.
when you put in like massive amounts of text, 200, 300, 400,000 tokens of text, it makes it harder for an LLM to reason about it. And I,
Hmm.
I know LLMs are constantly getting better and they will, but like why it's kind of like when CPUs get better and faster, like why do we need to fill it with more garbage? Let's just
Right.
take advantage of the faster CPU and have more clear instructions for it.
Right.
And
Makes
so
sense.
I feel like LLMs work the same way, and not only that, is it's much more like energy efficient as well
Hmm.
too. It's like so now you can potentially run an LLM locally on your machine instead of having to make a network call with hundreds of thousands of tokens to process it. So we have really simple instructions. It has to understand two modules, and then the code that it has to generate is also very small. So we're really not asking we're not asking it to do much, um, which is a really cool thing, I think, where we can really augment a human developer so the human really becomes the orchestrator. And if the
Hmm.
human so chooses, can use an AI tool to make that work go faster. Sort of the mundane, like non-creative
Hmm.
stuff.
Hmm. Hmm. I totally get that. And the idea is that for any given module or any given like primitive, there would be a templated demonstration of how it's meant to operate, maybe some kind of like documented API contract. And then the given LLM would be able to very quickly understand how to operate or how to engage with a given module and also how to engage between modules. I think that's maybe the part that I don't super understand is I get how we can say, okay, this is the emailer module and it can send emails and it can send them by like with these arguments, but it's not a simple like, oh, let's just bolt these two blocks together between a scheduler and an emailer, right? It feels like, is there an additional layer? Is there like a semantic layer that like normalizes how all of the modules interact with one another? It just sounds like there's a missing sort of translation layer. Am I
Yeah,
on the right track? Okay.
yeah, you're right. There is a missing translation layer. And that's implemented with something called an MCP server, which is a multi-context protocol, if I'm remembering the acronym correct. Um, so an MCP server is a plugin that lives within your local AI agent.
Hmm.
So like common AI agents today is Cursor, the integrated development environment, or Claude Code, which is the command line tool that a lot of people
Hmm.
are using.
Uh-huh.
Um, those live on your local machine on your laptop. And you can integrate plugins with them called MCP servers. And that MCP server basically answers questions that the LLM would have. So if you ask a large language model so it's like, let's take Cursor as an example. So in the Cursor agent, we ask it to we say we want to send scheduled emails. We want to fire off an email every time we have a new user who subscribes to our
Hmm.
service. Um, and then and we want to do that using the Kix framework. And that would be like the keyword for then the LLM would see like, okay, we want to use the Kix framework to do this. It would sort of like understand that we're already using the Kix framework in the project. Presumably we've already been doing some work with it. Um, and then it would ask the MCP server is like, okay, so give me more information about these two. How do I send an email using the Kix framework? And how do I detect when a new user has signed up using the Kix framework? And
Hmm.
how do I schedule a job? And the MCP server would respond with the documentation for those things.
Yep.
And then the LLM, because of its understanding of how code bases are built, would know
Hmm.
like, okay, so then we need to connect these two pieces together.
Hmm.
Um, and then we can listen to the database when a new user is created, and then we can schedule our email.
Got it. Got it. One of the things that we've talked about in the past is how this framework, the Kix framework, is a little bit the result of you doing like many small projects, like building many other applications. And this is sort of the sum total of that, almost like zooming back out, right? Like observing these outcomes and then saying, okay, how do I create a process? How do I create a function, right, that is going to consistently have these outputs? And I wonder, like, what has that been like? Like, how has it been odd trying to like extract like this bigger idea or this bigger mental model from like all of this work that you've done in the past?
Yeah, I think it's a lot of work. And it's a common path for open source frameworks in general to be,
Hmm.
extracted out of existing projects, usually multiple projects. Um, but I think what's really really exciting about it and what's been so much fun is that there's a lot of projects out there that developers would love to do. I know that I would love to do that are just they're cost prohibitive. So there's, like just little things, little hobby projects that you want to do here and there, but it would take too long to do it. It's a lot of developers, especially early and when we're younger and just getting started, like, oh, I could just do that in a weekend, and it turns out to be 5 or 6 weekends and then 10 weekends, and it's still not done, and you just kind of put it on the shelf and it collects dust because you don't have time to finish it. um so there's like really nifty little things, like there's an avalanche reporting website that I work on for backcountry skiers.
Hmm.
There's I work on stuff for some ice rinks, some scheduling systems for a hockey team. Well, it's multiple hockey teams within a single hockey program, a youth hockey program. And none of those are all like nonprofit organizations that don't have a lot of money, and
Right.
couldn't spend $100,000 with developers to build what turns out to be relatively sophisticated systems.
Hmm.
The Avalanche one, for example, that's all user generated content. So you have backcountry skiers and snowboarders who are out there taking videos and uploading videos and photos of the conditions that they see in the backcountry and reporting on that. So we need a mobile friendly website. We need to be able to process video. We need to be able to email them to let them know that it's been successfully uploaded. Then we email the
Hmm.
site administrators to let them know there's a new snow report, so that they can edit it if need be. So that's, I mean, these are really sophisticated systems, basically for no money. And so, what's the tipping point where it makes it worth it to be able to do that? Or if you have a framework that allows you to work really rapidly, then it becomes, you know, within the realm of possibility, within the realm of fun, to do it on a weekend, realistically,
Hmm.
which I think is just like really, really exciting.
I really like the mental model of how do we expand the realm of fun, right? Or rather, like how do we bring more things into it, right? Like what does it mean to
Yeah,
make an enjoyable experience apply to like many more potential projects? Because that also then sort of lowers the barrier of entry, right? Like as someone using the framework, as someone with some expertise, you're able to take on much more stuff or get the same output in less time, which is good.
exactly. Exactly. Fun for a developer, fun for a user, fun for the owner.
One of the things that really stands out to me in our conversations about the Kix framework, it sort of rhymes with or feels parallel to the idea of how humans develop expertise. Did you ever read that book Peak? Eric
I haven't.
Anderson, or maybe Anders Ericsson? I always get it wrong. Whatever I said first, I'm sure was wrong. And his whole concept of we have a few human pursuits that we can reliably create mastery in if you start early enough, right? The examples he uses are like chess and ballet, I think. And the idea is, look, if you start early enough, we have this like set of things that if you can do and you stick with it, then by the time you're 18, you'll be a master. And he sort of backs out of that in the same way that you're backing out of your individual projects to say, okay, what's the pattern here that predicts this outcome that we can understand it by? And I think his academic work is what informed Gladwell's like 10,000 hours outcome, right?
Oh, okay.
But in Peak, he discusses much more like it's actually not about like hours, it's about sort of quality and structured practice. And that what you're really seeking isn't to like play chess 100,000 times, but rather to get enough repetitions in that you move away from kind of the atomic movement of individual pieces and more into a mental model where you're observing and operating within like patterns and sort of broader concepts. And when you talk about Kix taking the need for a large language model to go from writing individual lines of code to instead being presented with models that it can then assemble, like that seems like the same sort of movement to me, right away from the kind of atomic pieces on the board, much more to, oh, this is a pattern that I recognize, and I have a few things that I can do to achieve the superior outcome here. How does that strike you?
Yeah. I mean, that's what large language models are: pattern recognition engines, really. Um, and they're fine tuned to recognize language, particularly structured language. So code is perfect for that.
Hmm.
It's structured. It's very easy to recognize those patterns, or relatively easy enough for an LLM to recognize those patterns. But then if you take it one level higher and you provide even more structure than code, it becomes even more deterministic, and the output is better,
Yeah.
higher quality output with lower amount of input, lower energy consumption, lower time. I mean, waiting for that network call for the, LLM to think about something for a couple minutes before it can output, 1,000 lines of code.
Yeah, I
We
mean that
we just
that like
jumped that whole step.
that maps so perfectly onto this idea of expertise, right? Because if you think about if I started playing hockey, right? Like if you and I went to go like do some stick and puck, it would be so effortful for me to skate in a straight line and to stop safely, right? Because I'm not expert at that. Whereas you have those components, you have those atomic behaviors dialed in. So you don't need to think, okay, I need to stop. Instead, you get to think at this higher level of like, oh, where's the puck going? Where do I need to be for this to be a success? Right? It's this same
Yeah.
idea, advancing from like the small atomic behaviors or lines of code to, okay, what are the patterns? Like what are the bigger outcomes that I'm trying to pursue? It's pretty interesting.
Yeah.
I'm genuinely thinking about this for the first time
It
right
is
now.
it is really
Uh,
interesting, and and it ties
oh,
back into fun, because if you take mountain biking as an
oh,
example,
yeah.
which is something that you and I share, is like there's a term in mountain biking that could be applied to like any physical activity, actually, anything in life really, called progression.
Hmm.
Where and mountain bikers use this a lot. Is like you work on a progression, so you pick a relatively easy obstacle and you work on that one and you get it, and then you pick a more difficult obstacle and you work on that one until you get it, until next thing you know, you can ride a whole trail full of medium to hard obstacles, and get in that flow state where it's challenging, but not impossible. And
Right.
it's a lot of fun, and it's a lot
Exactly
of
right.
fun to build things that way as well. It's like when um, I, I taught myself how to do masonry for a couple projects around the house. 2019, 2020, a lot of people were taking on new hobbies at that time. um, and it's just like it's really rewarding to build things that way. It was like, don't start with something that's overwhelming.
Right.
Start with like the small thing and build progressions. Yeah, it's fun. It's just like I think that's what keeps humans interested. Is if I can do this now, this is easy. Now I'll work on the next hard thing, and that's even
Yeah.
better.
It's my brother-in-law Lincoln, shout out to Lincoln Schofield, Lincoln Foley Schofield. One of the when we were talking about helping the kids learn to play instruments, because that's something that I sort of wish I had in my life, right? I understand people who are musicians get great satisfaction out of it. And he would say, don't worry about learning music. Don't worry about understanding, treble versus bass clef. Make sure that they can play a song that they want to sing along to. And like that's the first thing you need to do. And when I back out of that, I realize like, oh, this is actually the same model that we're kind of following with our kids for like sports, right? The idea isn't, how can you be the very best baseball player that there is? But instead, it's like, how do we help you get to a place where this is like, you have like competence of enjoyability, right? Like, how can we make it so anytime you can pick up a ball and a bat and just go enjoy it? Right. And I think that's also true for mountain biking, right? It's like, okay, how do you optimize your time such that, okay, I'm good enough that I can have fun, right? I don't need to be the very best. I need to have fun. And it seems like that's the same kind of model here, right?
Exactly. Exactly. Yeah. Fun. Developer fun. And being productive is fun. When you're building things, like being having the ability to be productive is what makes it fun and gets you into that flow state.
Mm-hmm.
Um to actually get something done, get that thing done, that grocery list app that you you want that just doesn't exist. You could do it on a Saturday.
So let's kind of talk about Kix like as an open source project, which is like when you think about the folks that you think can have the benefits that you're describing, build things more quickly, kind of engage with AI in a way that isn't environmentally horrifying, build things that are maybe for fun or maybe for money. Like, who are those folks, and like, how do we get this project kind of in front of them? Like, how do we get them tuned into Kix? Tell me, like what that ideal story looks like to you.
Yeah, I think it's really broad, which makes it challenging. I think probably need to focus and determine like who's going to get the most out of this, like who's going to feel the most productive and therefore get into the best flow state. And I think it's indie hackers, people that just like to build a lot of different projects, often for money, but sometimes not. It is like, I just don't think this is not something I think that, enterprise scale companies are going to be super interested in. It's really not, it's not built with a kind of robustness that they would expect. And it was probably kind of off-putting, but
Mm,
that's what's interesting about like a lot of things that come into the world that end up being successful, is that you have to have a worldview and understand that that means it's going to be polarizing. Some people are going to love it, and then some people are going to say it just doesn't work for me. Like, I don't know, it doesn't make sense to me, or it doesn't work in my role, or whatever the case. And I think that's okay, and we have to live with that. And just and dial it into the I would love for Kix to be the tool of choice for single operators, one or two
mhm.
people building really small things that want to get it done rapidly, hobbyists, um, small businesses. And I think we're stepping into an age where there's going to be a lot more independent individuals, that are working in groups of one or two or three, building really interesting things, that can sustain them in, financially, or just, small groups. I think that's really exciting.
Yeah, yeah, me too. It does feel like the zeitgeist is moving in that way, especially as we see, massive layoffs and headcount reductions among big tech companies, and what feels like a little bit of an inverse of what you're describing, which is so many software products, technical products are becoming, what we call like enshittification, right? They've been enshittified. They're meant to be everything for everybody, but they're losing all of their quality. They're losing all their hospitality and customer service. So now we've got this interesting combination of a large number of unemployed or underemployed tech professionals and an increasingly dissatisfied group of people with just incredibly generic, uninteresting solutions to their problems. And it does feel like there's maybe an interesting future there.
Yeah. Yeah.
Yeah.
I'm really excited about it.
All right, let's do shout outs. So in the show notes, I can link the Avalanche site. I can give a link to Peak, whether it's Anders Ericsson or Eric Anderson. I don't know. It won't be an affiliate link. It'll just be a link to the book. And then, of course, the Kix project itself. What is the right way for like one of these folks to start to get involved with the project? Should they go to kix.dev? Should they like watch or star the repo on GitHub? Like, how do you want people to move forward?
I think, well, first of all, one more shout out. There's an article by Anu, and I wish I could remember her last name, but she goes by the Twitter handle Anu, ANU. She's a great thinker in modern tech, and she wrote a piece, a blog post called "The Individual is the Platform," which is just fascinating for me, because it goes back to what we were just talking about, where one person may be able to amplify what they can do as an entity, as a business, in the very near future, and that's really exciting. So that's one. And then how to follow along or get involved with Kix. So the GitHub, GitHub/Kix, and then I think the best way also, like, I'm trying to post as frequently as I can. I've been heads down on a project recently, so I haven't as much, but I post as much as I can on Twitter and Threads and Blue Sky about what I'm building and sort of the decisions that are going into it.
Awesome. So we'll make sure that all your socials are kind of linked up and folks can follow along.
Awesome.
Cool. Thanks,
Thanks,
Kris.
Simon.
Done.